Welcome to our Business Intelligence series. Today we're going to talk about association rules. We're going to talk about association rules, the definition, then we're going to talk about the measures, how to calculate the support, confidence, and lift, and then we're going to show how to find association rules using a priori algorithm. Association rules is one of the tasks in business intelligence for identifying frequent patterns or co-occurrences in a given set of transaction data. It is also referred to as the market basket analysis for discovering combinations of items that are frequently purchased together. This is very important for companies or supermarkets to make placement for their items. They can place items next to one another so that customer can select or pick the items very easily. This is also important for the supermarket or companies to promote items through their advertisements. In summary, association rules facilitates organizations or companies to increase sales, product sales or services sales, and then to reduce costs. Cost here in terms of storage costs. Here in our data set D, we have 5 transactions, and each of the transactions contains selected item set. Those item set can be any items, okay? It can be rice 10 kilogram or 10 kg, fish, bread, milk, or eggs. In association rules, there is a term called support count, which means the frequency of an item set that occurs in the entire transactions. For example, the support count for milk is 4. This 4 represents the number of transactions that contain milk. So we have milk appears in transaction ID number 1, transaction ID number 3, transaction ID number 4, and transaction ID number 5. So there are 4 transactions that contain milk. How about the support count for bread? One, 2, 3, 4. Notice in transaction ID number 4, there are 2 bread items. So is it going to be 4 or 5 for the support count for bread? It is going to be 4 because we are more interested in the number of transactions. The number of transactions that contains bread is transaction ID number 5, transaction ID number 4, transaction ID number 2, and number 1. Irregardless of how many times an item appears in one transaction, we only count the one transaction. And the support count for fish is 2. We have transaction ID number 1 contain fish, and transaction ID number 3 that contain fish also. We also have a given minimum threshold count. For example, we have the minimum threshold count of 3 given to us, and whenever the support count of an item is greater than the minimum threshold count, the item is considered a frequent item set. So in this case, both milk and bread are frequent item set because their support count is greater than the minimum support count of 3. A rule takes the form of X arrow Y. X is referred to as the left-hand side argument or the antecedent, and Y is referred to as the right-hand side argument or the consequence. Other ways to read this is X implies Y, or in terms of a rule, you can say if item X is purchased, then item Y is also purchased. For example, you have milk implies cocoa. Customers who purchased milk will also purchase cocoa. This is a very simple rule. You can also have complex rule where X can be as many items as you wish. You can have cocoa, rice 10 kg implies milk. How about this one? Watching movie implies getting COVID-19. We must remember that implication means co-occurrence, not causality. So a rule does not mean the antecedent will cause the consequence. So we only calculate the co-occurrences, meaning to say the frequency of both events occurring at the same time. An association rule can be measured in terms of its interestingness by several factors, by several metrics, and we're going to cover only 3 of them here, namely support, confidence, and lift. So for a given rule X implies Y, we can calculate the support by having the support count for both X and Y divided by the total number of transactions. For the remaining metrics, confidence and lift, the numerator are the same. Okay, the value for the support count for both X and Y is going to be as the numerator for all the metrics, but the denominator will be different. For confidence, the denominator will be the support count for X, whereas the denominator for the lift is going to be the support count for X multiplied by the support count for Y. Let's look at these measures support. Okay, the formulas is given. The support equals to the support count for both X and Y divided by the total number of transactions. So we have 5 as the total number of transactions. So our denominator will be 5. And the support count for bread and cocoa. How many transactions that contain both bread and cocoa together? Okay, so we have bread and cocoa here. We have bread and cocoa here. So transaction ID number 4 and 5. There are 2 transactions that contain both bread and cocoa. So the support will be 2 divided by 5, which is equals to 0.4 or 40%. For the second rule, cocoa rice 10 kg implies milk. The support for this rule is 3 divided by 5 because there are 3 transactions that contain that contains all of these items: cocoa, rice 10 kg, and milk. Okay, so if you look here, we have transaction ID number 3 contain cocoa, rice 10 kg, and milk. Transaction ID number 4 also contain all the items, and transaction ID number 5. So we have 3 transactions that contain all of these items divided by 5 is going to be 0.6 or 60%. What does it mean, the support? For the first rule, 40% of the transactions contain both bread and cocoa. Okay, 40% of all the customers or of all the transactions contain bread and cocoa. Similarly, for the second rule, 60% of all the transactions contain cocoa, rice 10 kg, and milk. So the second rule of 60% has a greater, uh, a stronger rule because 60% is larger than 40%. The second rule is stronger than the first rule. The second metric is confidence, given by the support count for both x and y, divided by the support count for x, or the antecedent. We have previously the support count for bread and cocoa, which is 2 divided by the support count for bread, which is going to be 4. Okay, so there are 4 transactions contain bread, so 2 divided by 4 is going to be 0.5 or 50%. For the second rule, we have 3 as the support count for cocoa and rice 10 kg. So 3 divided by 3 is going to be 1.0 or 100%. So what does this value mean? 50% of the customers who purchased bread also purchased cocoa. 50% of those customers who purchase bread will also purchase cocoa. For the second rule, customers who purchase cocoa and rice 10 kg will purchase milk 100% of the time. So the second rule has a higher confidence and is much stronger than the first rule. The third metric is lift, given by the formula support count for both x and y divided by the support count for x multiplied by the support count for y. Now again we have the numerator for bread cocoa. The support count for bread and cocoa is 2, and we need to multiply by the support count for bread and the support count for cocoa. So there are 4 transactions that contain bread: 1, 2, 3, and 4. And for cocoa, we have 3 transactions: 1, 2, and 3. So we have 2 divided by 4 times 3 is going to be 0.167. And the lift for the second rule is 3 divided by 12, which is going to be 0.25. So what does it mean, 0.25 and 0.167? In lift, we have 3 types or 3 values that we're going to look into. Greater than 1, which is called positively correlated. If a value is less than 1, it's negatively correlated. Or if the value is equals to 1, it is independent. Meaning to say that the more, let's say for example for the x-axis, okay, the more you purchase x, the amount of y also increase. For the negatively correlated, the more amount you purchase x, the lesser amount of y is purchased. For the no correlation or independent event, the amount for y doesn't change irregardless of how many x you purchased. So for this rule, bread implies cocoa. It is 0.167 is less than 1, so it is negatively correlated. To interpret this lift, customers who purchase bread are 0.167 times more likely to also purchase cocoa than customers who do not purchase bread. Okay. Customers who purchase bread are 0.167 times more likely to purchase cocoa, which is not very good, okay, less than 1, okay, than customers who do not purchase bread. So customers who do not purchase bread has what do you call, has more inclination of buying cocoa. Previously, we were given the association rules and we were to calculate the support, confidence, and lift for the given rules. Now, we'll use an algorithm called the a priori algorithm to obtain the association rules. Using back our sample data, okay, and given the minimum support count of 3, we are going to go through the steps involved in the a priori algorithm. Okay. So the first step is to list a one item set support count. So for the given data set, we want to list down the individual item set. So we have banana, bread, all the way to rice 10 kg. And we want to find the support count. This count here means the support count. So banana, that appears only in one transaction. Okay, so banana appears in transaction number 3. Okay, so we have a number of one item set with the corresponding support count values. Next, we are going to eliminate item set that is less than the minimum support count, which is 3. Okay, so we are left with bread, cocoa, eggs, milk, and rice 10 kg. Okay, so those item set which is equals to 3 is still acceptable. Okay, so these are the one item set which fulfill the minimum support count, and then we're going to list two item set support count. How do we find the two item set support count? We'll make possible combinations of this one item set. So we have bread cocoa, we have bread eggs, bread milk, bread rice 10 kg, and the list goes on. Cocoa eggs, cocoa milk, cocoa rice 10 kg. So these are the possible combinations of two item set based on the one item set that we have previously figured out. Then we need to find the support count for the individual item set, the two item set. So bread and cocoa, we have 2 support count, okay, and we all the way to milk, rice 10 kg. You can pause the video to do your own calculation. Similarly, with this two item set, we want to eliminate item set that is less than the minimum support count of 3. So the remaining has either 3 or 4 as their support count. Next, we are going to list 3 item sets items and their corresponding support count from this list of 2 item set. How do we find the 3 item set? So let's look at here the first 2 on the list. We have bread, eggs, and bread and milk. So if we combine to make it 3 item set, we have bread, eggs, and milk because bread is the common item. Okay. Similarly, we have with cocoa, milk, cocoa, rice 10 kg, and we can have the 3 item set cocoa, milk, and rice 10 kg. So we do the possible combination. We have this 3 item set, okay, and we again find the support count for the 3-item set. Then we are going to eliminate item set that is less than the minimum support count of 3. And we are left with the remaining possible combination of bread, milk, rice 10 kg, and cocoa, milk, rice 10 kg. And we use this 3-item set to make our possible association rules. Okay. These are also called our frequent item sets because their support count is 3, which fulfill the minimum support count. So based on our frequent item set of 3-item set, bread, milk, rice 10 kg, and cocoa, milk, rice 10 kg, we're going to generate association rules and calculate the measures. I'm going to use only the first three-item set, which is bread, milk, and rice 10 kg, and we can do, these are the possible rules. We have bread implies milk, bread implies rice 10 kg, bread implies milk and rice 10 kg. You can do all possible combinations. I believe there are 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have calculated the support and confidence and also their lift. So apparently their lift is negatively correlated. Okay, definitely our data set is so small of only 5 transactions. Okay, we cannot see the trends more clearly, but we can use the support and confidence for now. Okay. The support and confidence, if we were to have a threshold level, the minimum support and confidence, let's say for example 70%, then we have only this rule: milk implies rice 10 kg with 80% and 100%, 80%, 100%. Only 2 rules that fulfill the minimum support and confidence level of 70%. Okay, if we were given that minimum values for support and confidence of 70%. Please double check the calculation. If there is an error, please inform me for updates. Okay, so we in the summary section, we have introduced the association rules. Basically, association rules help us to identify buying patterns, interesting associations or correlation relationships among a large set of data items, or of course our sample use only 5 transactions. Okay, and these are measured through support, confidence, and lift. We also talk about the measures. Okay, metrics such as support, confidence, and lift indicate the strength of an association rule. We also call this as interestingness of a rule. And lastly, we found association rules by using a priori algorithm. Okay, this algorithm is used to find frequent item sets, okay, which is above the given minimum threshold value, and these frequent item sets can be used to generate association rules with their corresponding metrics. Thank you very much.